Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on the variation of velocity and acceleration in the suction and delivery pipes due to acceleration of the piston. So the theory and derivation part we have done in our previous lectures. So based on that formula, we will solve this problem. So here I have taken the question of the cylinder bore diameter of a single acting reciprocating pump. So the pump is single acting reciprocating pump, and the diameter of this pump is bore diameter is given 150 millimeter, and its stroke length is given 300 millimeter. The pump runs at 50 rpm. So the pump is running at 50 rpm and lifts water through a height of 25 meter. So this is the height of lifting grid is given. H head is given. Delivery pipe is 22 millimeter long and 100 millimeter diameter. So this is the delivery pipe length and diameters are given. Find the theoretical discharge and theoretical power required to run the pump. If the actual discharge is 4.2 liter per second, find the percentage of slip. Also determine the acceleration head at the beginning and in the middle of the delivery strokes. So we need to calculate a lot of things here. They're given one by one steps like theoretical discharge. The first step we need to calculate the theoretical discharge. Then we need to calculate the theoretical power. Then after that percentage of slip. Then we need to determine the acceleration head at the beginning and at the middle of the delivery strokes. So we need to calculate 5 to 6 terms we need to calculate. So first of all, we'll see what are the data are given. So I'll write the data given here. Then we'll see what are the formula can be used to calculate this problem. Okay. So first one, the diameter and bore diameter is given. So diameter of the cylinder. So D, I can write this is 150. This is millimeter, and this one we can write 0.15 meter. Similarly, the stroke length is given. So the stroke length, here we can write the stroke length, which is considered as L, and the L is given 300 millimeter. So 300 millimeter also we need to convert into meter. So this one also we can write 0.3 meter. And after that, the pump runs at 50 rpm. So the pump is running at a speed of rpm speed, that is n. So we can write this is 50 rpm. Okay, this is our speed. And after that, it lifts water through a height of 25 meter. So the head is given. So head is given. This is h equal to 25 meter. This is the total height. Then the length of the length of the delivery pipe is given. So this one we can take a small l, a suffix or a subscript we can write d. This is of 22 meter, and the diameter of this also given. So this one also diameter small d, fixed subscript d. We can write this is 100 millimeter. So this is the diameter of the delivery pipe. This is 100 millimeter, and we can write this is 0.1 meter. So these are the data are given. Yeah, one more data also given in the question itself, like 4.2 liter per second actual discharge. So okay, so let's write Q actual. Q actual we can write this is 4.2 liter per second. And this 4.2 liter per second, if I'll convert this by meter cube per second, then I need to divide 1000 by this. So it will get 0.0042 meter cube per second. So these are the data are given. Now first you can see the theoretical discharge we need to calculate. So let's solve this. Here I'll write the solution. The solution first, as I told you that we are going to calculate first point that is given theoretical discharge. So QTH. When the QTH, QTH is two things are there. One is 2 ln by 60, another one is ln by 60. So ln by 60 is used for the single acting reciprocating pump. If it is given a double acting reciprocating pump, then we could have used 2 ln by 60. Now here only ln by 60, this formula will be used. So by this formula we can calculate this theoretical discharge. So area diameter is given, area need to be calculated here. So let me write here area equal to, this is pi by 4 d square, so this is pi by 4 to 0.15 square. So that value I need to write here. Okay, I'll solve it and write. Remaining value, this is L is given, so L is 0.3 and N speed is given 50, and this divided by 60. So this is our theoretical discharge. So first let's find out the area of this. So 0.15 square, that means 0.20225 into pi, and this divided by 4. So 0.017 67 is given. So let me turn off this. Yeah, so here I got 0.01767, 0.01767. So the same value I'll write here, 0.01767 meter square. This is the area, and along with this value also, let me calculate this area, like discharge, multiply 0.3 multiply 50 whole divided by 60, and this is our theoretical discharge, 0.0044. okay, so 4417, 0.004417, and this is meter cube per second. Okay, only for we can also write. So this is our actual discharge and this is our theoretical discharge. Okay, now the next thing is we need to calculate. The first thing is completed. Second thing is theoretical power. So the theoretical power, if you see, this is I'll write PTH. Okay, theoretical power. So theoretical power will be calculated same thing like a theoretical weight of water to be lifted, and what is the total height need to be lifted, and divided by 1000. The 1000 will be used for the kilowatt. So here also the formula will be used for this, like rho g, and here q, rho g qh divided by this 1000. This is the formula for the power. But here, though it is asked to calculate the theoretical power, so here also the discharge I'll take theoretical discharge. Okay, and here the value I'll put it here. So you can see this rho can be cancelled here because this is also 1000, this is also 1000. So I'll put this value of 9.81, and this value is 0.004417 into h. So h is how much? So this h is actually 25 here. Okay, so h is 25. Now the value what we got here, if I multiply in this, that means multiply 9.81 and multiply, this is 25, multiply 0.00, this is 447. Okay, so we got the value like 0. This is the value into 9.81 into 25 into this. So what we got here, the 1000 cancelled. I hope X is there. Let me do it again. So let me take this calculator, and here the value of this G is 9.81 and multiply. Okay, 2 times we have multiplied, that's why it came different. 0.00447 into 25. Okay, so this is the value 1.096. So it's actually 1. Into it, which is 9.81 into 0.004417 into 25, 1.0832. So we got this theoretical power, that is 1.0832, and this much kilowatt. This is the another answer. Okay, this is 17. So first answer, second answer we have calculated. The third question is asked the percentage of sleep. So the percentage of sleep also formula we know. So we can write the percentage of sleep. So this can be calculated like a theoretical discharge minus actual discharge, and divided by this QTH into 100. So the 100 is for the percentage. Now here already we have calculated. So the theoretical discharge, yeah, this one, and the actual is this one. And finally, so let me solve it. Let's see how much it is coming. Theoretical, how much? 0 0.000417 and minus 0.0042 divided by this is 0.004417 and multiply 100. So 4.912. So this is the answer, 4.9128. 4.9128, and which is nothing but I can write the is 4.92 percentage. So this is another one answer. Okay, so these are the formulas are used here. Okay, and the next one is we need to calculate the next point is, that is acceleration of head at the beginning and delivery stage of the stroke. So we know this formula, acceleration head, that is HAD, and this HAD equal to, we have seen the formula for the delivery pipe we need to consider, that's why LD I am writing. So LD by G into, and this capital A by small a, the small a d into omega square R, and this is cos theta. Actually this is the formula here, and for this formula we need to find out the determine acceleration head at the beginning and at the middle of the delivery strokes. So here if you see these are the values are required for us. LD is given, G value known, area also known, omega square. So area of this actually area of the delivery pipe we need to calculate here, that is AD equal to, again the same thing I'll write here, like I can write pi by 4 d square. So diameter is given here. If you see the diameter, this is the diameter is given. This diameter is different and this diameter is different. So I need to put this value of this diameter 0.1 square. So if I write this pi by 4, so this value multiply of this. So anyway, let's solve it. This is 0.1 square into pi and divided by 4. 0.00785. So this is 0.00785. This is the area of the delivery pipe. Okay, and capital I is already known. Then we need to calculate the omega. So here omega equal to, this is angular speed. So angular speed, we know that formula, that is 2 pi n by 60. So here 2 into pi, so what is the speed value, that is 50 rpm, and divided by 60. So now I'll cancel this 3. So 3.14, 3.3. So it will be there 1.05 something will be there, multiply 5. So it will be like 5.2 something will come. Okay, this is omega. Now the next one value here, if you see, this is given, this is known, this is also known, this is calculated, omega calculated. Now we need to calculate the radius, crank radius. So crank radius will be calculated. I'll go to the next page. Yeah, so the crank radius will be L or R, you can calculate, that is L by 2. Okay, this L by 2 is nothing but I can write the length 0.3 and divided by 2, that is 0.15, this much meter. Now we can calculate the value of HAD. So HAD is nothing but the delivery head. Okay, so acceleration due to delivery head, the delivery head. So the formula we need to write. So let me see the formula again. LD by G. So LD is 22 meter. G value known. So this is 22 by, this is 9.81. I'll write this value into the area we have calculated. We see the area value how much, 0.01767. So 0.01767, and the small area that is AD 0.00785, 0.00785, and this into here, if you see, that is the value omega square is there, omega here 5.2, 2 3 something was there. Actually I have written only 5.2, so some value is there that I will write here. So that is omega, and here let me write this is 5.23 square, and r is here I have calculated 0.15 into cos theta. So cos theta actually, yeah, cos theta. Now theta value actually here is given. No, theta value is not given. Yeah, we need to see the question. In the question itself given at the beginning of the stage, at the middle of the stage. So in this point we need to understood that. So the theta will be at the beginning. The theta will be 0 degree, and at the middle of this stroke will be theta will be 90 degree. So you need to put theta equal to 0 degree here. Now here if you see the cos theta value is okay. The cos theta 0 degree. That means cos 0 degree equal to, that is you can write 1. So yeah, so if let me write the value here, so that will go for cos theta, will keep it in the last. So this value if I solve it, and finally we can keep the theta, then we can put the value of theta here at the starting and the middle. So let me calculate this HAD. Okay, let's see. We need to take the help of this calculator. Now we'll go one by one. 5.23 square multiply, this is 22 into 0.01767 and into 0.15 into, yeah, 0.15 up to this is enough. Put 1. Okay. So square root of 5.23, then multiply 22, multiply here 0.0016, yeah, then 0.15, yeah, this is the value. Now whole divided by, let me start the bracket, and here 9.81 multiply 0.00785 and bracket close, 20.711. So we got the value here, at least some value we got here, that is 20.711, this much cos theta. Now it is very simple for us. So now I'll take for the beginning of the stage. So you can write for the beginning of the stage. Beginning of the stage, the theta value will be 0 degree. Beginning of the stage, theta equal to 0. So here cos theta equal to cos 0 degree equal to here 1. Okay, so we can put the value for the first point at the beginning. We can write HAD equal to, that is how much we got, the same thing we'll write this HAD equal to this much meter. Okay, and the second point is at the middle of this stroke. Okay, so the acceleration head at the middle of the delivery stroke, so that will be 90 degree. So HAD, let's write HAD, this is 20.711 and this is cos theta, and here cos theta value will be put 90 degree, that is 20.711, this is cos 90 degree. So cos 90 degree is nothing but 0 degree, 0. So here we'll get the value of 0. This is another one answer. So this is one answer and this is another one answer. So I hope you understand how to solve the problem. Only thing is we need to remember a few formulas of this, and based on the formula we can solve it easily. So I hope you understand the lecture. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.